All right. So for lesson 5.3, we are actually going to be talking about lines and slopes. So all of the information we've had about graphs and points on a graph is going to help with this information. So most of this is fairly straightforward. If you have a graph like this, and there's our center, and let's say that is 1, 1, -1, -1, and we draw a line through that. What we want to know is the slope. Well, the slope is equal to the rise over the run. So start here at 0, 0, and the rise is 1, so we went up 1, and the run is 1. So rise is how far up or down you have to go, and run is how far right or left you have to go to get from one point to the next point on a line. So our slope is 1 over 1, which equals 1. Okay, so rise over run. So let's look at the examples they give us in the book. That one's a fairly easy one. If your line goes through the axis of your graph and falls on points 1, 1, 2, 2, you can tell right away that your slope is going to be 1. But if you have something like this, and we have points at -1, -2, so nope, that's not right. It's -2, -1. There's our first point. And our second point is -4 up 3. 1, 2, 3. And we have a line that goes through that. Oops. One thing I am not good at is drawing lines without a ruler. So, may not be completely straight, but it's going in the right direction. So, there's our line. And we have these 2 points. We have -2 and -1. And we have -4, +3. And they want to know the slope. Well, first, is our slope positive or negative? Anytime your line goes this direction, it's negative. If your line goes that direction, it's positive. But we can also look and figure that out by checking our slope. So remember, our slope equals rise over run, and our rise from this point to this point is 1, 2, 3, 4. Nope, yes. 1, 2, 3, 4. So our rise is +4. And our run is to the left, so that's -1, 2. So 4 over -2 is our slope. We can simplify that into -2. Our slope is -2. Our rise is 4, and our run is -2. Now you could do it the other way and start with your run and have a positive run of 2 and a negative run of 4, but either way, our answer is going to be -2. Our slope is -2. So let's try the next example they have. Okay, so the first point on this line is -3, -3, And then the next point is 0, -1. Those are our 2 points, and we draw a line connecting them. And they want us to find the slope. So we write rise over run, and we do our rise, which is 2, and our run, which is 1, 2, 3, and our slope is a positive 2/3. Okay, so this is fairly easy. If you graph it and you draw your line, you should just be able to count what your slope is. Count your rise and then count your run, and that's your slope. So let's look at example 2. It says, what if they give you the slope and a point on the graph? Could you draw the line? So they're going to give you a point, and they're going to give you the slope, and then you have to figure out how to graph it. So the point they're going to give us is -3, 2. So we're going to go 1, 2, -3, 2. So there's our first point, right? And our rise is, our slope is -3 over 4. That's our slope. So this is our rise over run. So our rise is -3, so you go 1, 2, 3, and our run is 4. 1, 2, 3, 4. So there's the next point on our line, and all you have to do is get a ruler or a straight edge, connect your dots, and that's the line. Now you could find the rise and the run in the other direction as well to make sure your line is straight, right? So then that would be, just do the reverse. Do -3, or do a +3, sorry. So 1, 2, 3, and a -4. 1, 2, and it'd be over here somewhere. So, all right, let's try that again with a slope and a point and see if we can graph another one. So let's draw our graph, and I definitely am going to need a new marker here soon because this one is dying. All right, and they give us a point of -1, -2. Okay, so there's our point. And our slope equals 3. So we want to put that into a rise over run fraction, so it's going to be 3 over 1. So we have a rise of 3, so we go up 3, 1, 2, 3, and over 1. And there's our second point. And we just take a straight edge or a ruler and draw a line through our 2 points. Okay, that was not a very good line, but you get the point. And if you look at the picture, it's pretty close to the same line. Okay, so our slope, remember, is rise over run equals your slope. So finding your slope, you just count your rise and your run. And if you go down, it's negative, and if you come to the left, it's negative. Okay, so the next thing that it has in the book is it says, the ratio of two quantities that change, such as slope, is a rate of change. So your slope is your rate of change. How is our line changing as we move in this direction, right? It is changing this way, or maybe it's going to change this way. It depends on how steep it is and what direction it's going, determines our rate of change. Now, a constant rate of change is a line, because the slope is the same throughout the entire line. No matter where you go on any point on the line and count the rise over the run, you're going to get the same thing. If you have a graph of something that is not a line, like a parabola, and it looks like this, your rate of change is variable or not constant, because your slope is going to be different throughout this entire graph. Okay, so if you have just a line, then it is a constant rate of change. If you have something like a parabola, it is a variable rate of change. Okay, so the last problem we have is a distance with a bicyclist who travels over time, and they want to know, does the bicycle travel at a constant or variable speed, and how fast does the bicyclist travel? So they have a line in the book, and if you look at it, it gives us our rise over run, which is 15 over 1, and you can see that he's traveling 15 miles per hour. Okay, we don't really need to work through that problem because it's given to you in the book. So the first two problems, what you're going to do is just tell me if they're positive or negative, and then the next set of problems you're going to have to graph the line, which means you'll need to draw graphs for each of these. I would prefer if you would draw little graphs for each one instead of a giant graph where you plot all of the lines. It's going to be really confusing with the lines. And then the third section, you're going to do tell me if it's a constant or variable rate of change. So looking at the graphs, is it constant or variable? And you are going to be doing all of the problems 1 through 20. So if you don't have any questions, you can go ahead and get started on the problems. If you do have questions, raise your hand and I'll come and help you.